how does one incorporate network into economics? This is of course an enormous topic, and we heard lots of interesting work on it already today. So I mean, I don't know that I'm going to be able to kind of, the goal here is not to kind of claim something deeply original, but just to set down a set of ideas. So I think there are three questions I'll try to discuss, and then presumably many more. One is, I think, how much of, when we think of networks, I think for a very natural set of reasons, we're going to have to think about, what motivates people for acting within networks, and many of those motivations are not going to be because they're going to make more money this way. And I think that's super important, because I think that's what, I think for me, and this is, I think I remember saying this in that talk that Ben just mentioned, that it seems to me that what network economics kind of maybe slightly fortuitously did was to open the door on saying that, not every choice is made for economic reasons. And I think that's a very important reason why I value this field, is that I think it's sort of, I think we kind of painted ourselves into a corner by assuming always that all actions are motivated by economic decision making, sort of very clear economic reasons, and I think being liberated from that was useful. That said, I think it remains an open question, and I think one that we need to think about empirical ways of getting at. A second question, which is related but distinct, is where do these connections come from, and to what extent should we take more statistical models of this? There are, as we saw today, the statistical models of network formation, which are basically black box. The reason there is an extreme value distribution that explains why two people are connected, mostly over and above some observables, but how seriously should we think about the extreme value part of it, which is really saying that there's something, when I meet somebody, there's some chemistry, and how much it should be that there is some design, and that's the two separate questions. One is just at the individual level, is it the case that we get motivated to join certain things by certain social forces, or second, is it the case that when we join networks, we internalize what that means for everybody else? So those are two separate pieces. A design network has both pieces. It's both one where we individually, the incentives provided to us are adequate, and they internalize the social externalities. Both of those pieces are potentially not obvious. It may well be that when we join networks, we don't think that we're joining networks, and second, even if we thought about it, we don't think about all the spillovers that would come from that, plausibly. So I think both parts of that are interesting. And finally, sophisticated versus naive decision makers, and to what extent, when we take these decisions, do we actually internalize the nature of information flows within the system, or the impact of my joining a particular group on other people, all of the senses in which I could be more or less clever in optimizing. So I think in each of these, so what I'll try to talk about is a little bit on each of these, and try to say something about bits of research which kind of address some of these questions. There will be very, 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 very preliminary, and therefore the main point of the talk hopefully is to leave you with some sense that it's possible to make progress, and therefore you should do it. Okay, so what motivates network actors? This, of course, is not at some level it's not different from any other context of economics. People's motivations are complicated. We kind of know that. Introspection tells us that, but we of course then have to kind of find a way to make that operational in any specific piece of research we do. So, and we make, I think, choices, and sometimes the right choices, which is that, you know, maybe even though there are 20 motivations, the one motivation that we can model very well is the economic one, and so we hold on to it. But that doesn't mean necessarily that that choice is context free, that in particular contexts there may well be that certain choices we make which might be very good for modeling how you know, a pharma company prices its medicine may not be the same good model for looking at how you know, two people who meet in a tea shop connect to each other. Those are potentially different questions, and there's no reason to think that there is some one methodological premise that should dominate. So, as you know, people interact in many different ways. Some of those are economically kind of, we understand the economic structures of those, many of those we don't. But of course, there's no reason to think that they don't have spillovers. So the fact that we happen to be talking has consequences sometimes for things that information that we pass on even without meaning to. So it's not that I price the information I pass on. And so this is sort of saying the same points, and I think there's a whole range of views taken within the literature. You go from sort of models of infection models, where if I have information, somebody connected to me with some probability has that information. Essentially, the connection is entirely orthogonal to whatever happens. It's like, we happen to have a connection, and then things happen as a result of that. That's one extreme. The other extreme in development economics, we have lots of kind of studies of collective insurance where the optimization is central. In some sense, who will deviate from this because their particular, their shocks happen to have a particular relationship with the shocks of everybody else, and we model that and we try to predict. And both exercises are meaningful. There's no way taking a view that you should never do one or the other, but I think I would like to be able to say what is maybe if I had to think of the default assumption, what's the right default assumption for a particular context, and that's maybe the useful question. So here's an experiment where I think so if you think of this world where people kind of are, take the world of network communication, this is a world where people are very, very we usually model it as people being very kind of mechanical in the way they act, and I'm going to try to argue that there is lots of evidence that people are quite strategic. Okay, so they what they say and they don't say, and I don't mean strategic necessarily in the sense of trying to make money, but they make choices. It's paper with Ben, Emily Breza, and Arun, and it's about this kind of bizarre thing that the Indian government did. On November 8th, which remarkably was also the day when Trump was elected, it was just a day the Indian government decided that they couldn't be outdone by the Americans. So the two highest denomination of bills were demonetized, meaning they were given 52 days to deposit the bill in bank accounts. Turns out that this was done in an extremely ham-handed way, in the sense that they hadn't figured out, for example, that the new 2,000 rupee bill did not fit in the ATM machines that they had. So therefore, they couldn't give out the 2,000 rupee bills, etc., etc. So as a result, there were 54 rule changes in 42 days, and people were justifiably quite confused. Every day, two rules could change, and somewhere there were many which were one step forward, two step back kinds of changes, so people got deeply confused. What was our intervention? Our intervention was to distribute information about what the correct rules were. This was done in the last 10 days of this experiment, when the rules had actually stabilized, because otherwise it's hard to give out information about rules. Which one, yesterday's or tomorrow's? So and what we're going to do is we're going to vary the distribution around 2 dimensions. This was done in 225 villages, and the question was, what's the best way to distribute the information? Okay, so I want to give out information. I want to tell people, what the rules are, but I can do it in one of 4 ways. I could inform everybody, or I could inform a small number of people, and second, I could inform everybody whether the information was given to everybody else or not. I could tell people that I could tell people, here only 5 people got it, you are not on the list, but these people are on that list. Or I could tell people everybody got it, including you, or I could say nothing. I could say you got the information, and say nothing else. And so I'm going to vary, the experiment will vary both of these things. So it's a field experiment where we're going to vary both of these things. So we measured impact along 3 dimensions. Was there more discussion of demonetization? That's one obvious outcome, is where people actually talking more about it. Second, were people more informed? Actually, did they get, I gave out information, I varied that, did they get more? And finally, just to see if this has any behavioral impact, we offered people a choice between 2 100 rupee bills. 100 rupee bills, everybody knew, were continued to be legal. So there was no change in their legal status. So we could offer them 2 100 rupee bills, or we could offer them 1 500 rupee bill. And it turned out, I won't go into too much of the details, but it's the 500 rupee bill was still legal at this point, and you could not use it as a currency, but you could take it to a bank and deposit it. And in the paper we document that everybody had a bank account, and that the bank was 20 minutes away and would take 15 minutes to cash the amount. So that's about, let's say, an hour total outside to get the money. And this is about between 1.5 and 2 days extra wages. So the wages were a bit below 200 rupees a day. So this is period where employment is very scarce. So this is period where nothing's happening. So therefore, quite a lot of 300 rupees difference is not a trivial difference. It's between 1.5 and 2 days wages. So so are they making the right choice? And you can think of reasons, and they tell you reasons why they may not make that choice. They say that, look, the money, we actually ask them, why didn't you take it if they didn't take it? And they say, the money is not, you can't do anything with it, it's worthless, so why would we take it? So there were very clearly people were not fully informed. So this is, now I'll show you some results. This is sort of the very reduced form. So these are the village, the randomization is the village level. So all of these are simply means, but I think the means are reasonably easy to interpret. And I'll tell you, these don't show standard errors, but I'll tell you a little bit about those as well. So basically, this is the pattern we're going to see all the time. And so this is on conversations. Seed means I gave to 5 people. Broadcast means I gave it to everybody. Okay, and then common knowledge and no common knowledge. So seed, no common knowledge means I take to 4 to 5 people. I didn't tell them. That doesn't lead to a lot of conversations. But interestingly, broadcast common knowledge also doesn't lead to a lot of conversations. Maybe that's not surprising. If people got the information, they understood what the information was, they shouldn't talk about it. It's fine. It's the sun rises. We don't talk about it. So it's not obvious. This is not particularly surprising. It fits with what I'll show you in a minute. And this is I'll skip the intermediate step, but the intermediate step is exactly like this. And so you have to believe me, you can look at the paper. So seed no common knowledge generates the lowest fraction. About 5% people actually take the 500 rupee note. But also broadcast common knowledge does much worse than broadcast no common knowledge. And so these differences are significant. In fact, this is also significantly bigger than that. So both of these differences are significant. So first statement, what should now surprise you is if you think of the most naive models of information transmission, this one should do well. I told you what the information is, and if you don't know it, you can go and ask somebody else, and everybody else knows it. So you should have good decision making here. You have bad decision making. This does much worse than this one. Why would that be the case? And I think our sense is that we need to have strategic participation in the social learning process. So to explain this, so everyone is informed and knows everyone else has the information, then when you go and ask a question, then you are saying, yeah, they told me this, but I don't know what it means. Because everybody knows that you ought to know. So you're exposing your ignorance when you actually confess to not having the information. Whereas, and as I said, the information has exactly the same pattern. So if you ask people questions on different things, the errors have exactly the same pattern. They're ordered exactly in the same way. So this is all kind of very closely aligned with each other. So what's going on? So if few people are informed and everybody knows that, it's great, because then there's no shame in asking. I've been told that you are the one who's informed, and I'm going to ask you this question. So you gave me the information, but I didn't understand it, which is not surprising, given that these people, they can read, but they're not necessarily fluent readers, and there's complicated stuff there, and so it's not at all clear that they should have understood, but then they can ask questions. And then if it's broadcast no common knowledge, then of course you've given the information, so you could get it directly, and if not, there is no presumption. Nobody else knows that you ought to know, and therefore you can go and ask questions. And so I think in terms of just this sort of aside from what I want to say, in terms of policy implications, actually turns out that it might be better to just tell a few people, because it's very hard to do broadcast no common knowledge. It's not an easy technology. You have to tell everybody, but make sure that nobody else knows. That's a hard thing to do. We could do it, but it's expensive. So usually the way you broadcast is you just have a loudspeaker and you announce. And that of course gets you broadcast and common knowledge. So as in fact the natural policy option is probably this one. And so it says, so it's not just that I want to make a point about people being strategic, and that this is something that when we model social learning, the listener is almost never modeled. And I think the listener is important, and in some sense I think thinking about motivation here is important. Continue. So how do we know that this is the right story? Well, Ben, Arun, and one of their co-author have this other experiment, a lab experiment, where they look at whether or not they basically give people again a choice, and this is much more of a lab experiment in the sense that the choice is artificial. It's not that there's not a it's a much more structured choice, and they show very clearly that people are reluctant to ask because asking will reveal them to be less smart. So the way they set it up is basically there's a correlation built into that for, between understanding the information and being smart, and they then prime that, and they see that people actually, when that's primed, they actually are unwilling to ask. And when you actually, in terms of, we did recently a retrospective survey, and again, 71% of the villagers said they did not understand what was going on. 75% said they would feel judged if they didn't know and ask these questions, and 79% said they reduced the willingness to talk about this issue. So it's sort of it hangs together. It's people. I don't put huge amount of weight on self declarations, but nonetheless, it sort of all works out. Here's the opposite, in a sense, is that I showed you that people are strategic. Some people are strategic in asking. I want to now show you that some people are not strategic in talking, in a sense, and so these are two field experiments we did, which are with Arun, Esther, and Matt Jackson, and these are asking very similar questions. How do you diffuse information? Who do you inform? Who are the best seeds in the community? So instead of, in fact, the previous experiment, we used the result from this one, which I'll tell you in a minute. We made use of it. When we chose the seeds, we used the result of this experiment. So that was actually coming to them in a sense, reverse order. So network theory gives you a very simple answer, which is that you get some version of eigenvector centrality. You want to be people who are connected to connected people. So it's a very clear answer, and we have some evidence suggesting that when you give information to more central people, you get more transmissions. The problem is, how do you know who's central? That's always a problem. So we went the other way. We said, maybe everybody knows the village gossip. So could we just use gossips instead of, so village gossip is someone who really likes to talk. So, do people know who that is? So these are the two field experiments. First thing we did was we asked 15 people randomly chosen in each village on who would be the best to spread information about a fair or a financial product. So we just asked 15 people. What's remarkable is that 4% of the households were nominated. So it's not that everybody says, a different person. Only 4% of the households were nominated to be these gossips, and every nominee gets 9 nominations. So everybody agrees who the gossip is. That's point number one. Point number two is that these are not their friends. Typically, the highest degree is 2 or 3. Depending on exactly the setting. So they're not naming their friends, they're naming other people. Moreover, we show that if you look at the centrality of who they say, their prediction of centrality is very accurate. Meaning, if you are at 2 remove, 1 remove, or 3 remove, the predicted centrality is the same. So they actually are as good at being right in each case. Finally, so what do? We randomize either it turned out it doesn't matter whether you seed 3 or 5 people, so I'm not going to emphasize that, though that's experimental result is there. You can either seed gossips, elders, or random people. Elders are kind of the solid citizens of the village. Okay, so you can seed one of these 3 people, and the information was about a free raffle that you had to call to join. So it was very easy to join this raffle. All you have to do is call a number, and nobody would pick up. So the number would be your number would be recorded, and if you record your number, you'll be put into a raffle. We went to pains to explain that the raffle was non-rival, so there's no reason to. So we said that we're going to roll 2 dice, and if you get 2 6s, you will win. So it was very, very clear, and you win a cell phone, quite a nice cell phone. So this was, we worked with a cell phone company, so it was kind of credible, the whole thing. Okay, so that's the experiment. Here's the result. Essentially, this is, blue is random, black is elders, and this is gossips. So this is the CDF of how many calls you get per village. And you can see that the CDF is shifted way to the right. If you give the gossips are just brilliant. I mean, they essentially, there's a little bit of cleaning you need to do here to exactly interpret it. The reason is that some of these leaders are also gossips, or elders are also gossips. So you have to, but if you take that out and look at, so you do the IV, then what you get is that a gossip is 3 times as good at spreading the information. So you really reach many more people by using gossips. So then when we showed this result, people said, well, that's sort of, this is about some raffle, who cares? If the information is important, you can't use gossips. So we did a second experiment. This was spreading information about immunization camps. So this is like camps where you can bring your child to get immunized. And the problem here is people don't have enough maybe faith in these things. They don't necessarily go, so some social encouragement is useful. If somebody, maybe an important citizen in the village tells you, that you should go do it, you might do it. So here we compared gossips actually with the theory that people offered, which is trusted people, who are the solid citizens who everybody trusts, and random seed. The outcome was the number of children immunized. So much more of a welfare relevant outcome than participation in a raffle. And the answer is, you basically see that the gossips do much better, and they have about twice as many children get vaccines. And this is true. We have better data than this table now, and so you can look at it. It's true not just on the mean, at the mean, but at all points in the distribution. So it's true. You do quantile regression, you see it's true everywhere. The gossips just do better everywhere. It increases the number of, and trust. It's better than trusted people. Even trusted gossips. Trust seems to be a bad rather than a good. I think mostly because trusted people are very busy. They don't actually go and gossip. You need people who have the time to go and those kinds of people basically. So you need those people, and it increases number of children immunized by 20%. So this is a substantial welfare gain. Now, one other thing, because we had these random, a set of villages, a third of the villages we gave it to random people. Some of those random people will be central, and others will be less central. So we have variation in whether or not they are central, whether or not they are gossips. There's all of that, because in the random segment of this, the 71 villages which were random, we have variation. So some villages, the people hit by the random were gossips. Some villages, the people hit by the random were people who are high centrality. We actually knew the centrality. We didn't use it for this. And so we can actually look at the difference between these two. And the point is that conditional on their centrality. So conditional on their centrality, being gossip helps as well. Let me say one more last thing. Why do people know who's central? So why would people know who's central? So we have a little theory in the paper showing why people will, how do you learn who's central? Well, if you hear stories which are associated with people, so you hear that X has bought a car or bought a cow, more relevantly a cow, I think. and you hear a lot more about some people, then those people talk more. So if you take that model and you you can show that basically over time the ordering of people you hear about will converge to the order of who talks a lot. It's not rocket science. So, but nevertheless, controlling for centrality, it matters that you're a gossip. So half of the gain from being a gossip is that you're central, because of course you talk to a lot of people, you become central. But half of the gain is for being a gossip, meaning you like to talk. So being somebody who likes to talk. So I think this is important because it's saying that at some level we have a theory which sort of tries to take out all the individual heterogeneity. It's just connections is the kind of the bread and butter of network theory is connections. And this is saying that a substantial part of the gains comes from things that are not connections. It comes from people's desire to talk. And in that sense, just going back to the original question, how do we model behavior on the network? I think this is an important part of that. So summarize, some people are shy, and you putting them in a very information rich environment may not help them. Other people are love to talk, and they will talk your ears off, and that's also important. So I think the heterogeneity here is important in ways that we haven't really exploited. And neither may be responding to pure economic incentives, or at least ones we can easily manipulate. Your image concerns about asking somebody a question are not things that are subject to economic incentives, really. It's like, you may very well be. Okay. Second question, I said random versus design networks. Should we think of the world as being? So here, I think the traditional from sociology is mostly that you should think of these as being networks that are statistically generated, if you like. Economists often talk about design networks, and there's lots of insightful work on design networks. And then there is some nice theory which in a sense is now from many years ago, for example, Jackson Walensky or Bloch Jackson, showing basically that there is no particular presumption that individual decisions will generate optimal networks. You can easily imagine why all kinds of externalities, so you can easily imagine why individual decisions don't generate optimal networks. We're sort of interested in this class of issues. Again, how do you get an empirical handle on this? So I'm going to show you results from two separate studies. One is more a panel data study and one is an experiment. So this one is from 75 villages for which we have detailed network data, really very, very detailed network data before microfinance entered these villages and 5 years after. And it's think of it as a village level panel. Do the networks change? Well, they change. The link density goes down by 12% more in the microfinance villages. So the microfinance villages, the network shrinks. Is it causal? We can do a cross-sectional comparisons of a place where we did a randomized control trial of microfinance enter versus not, and we find very similar results, that the network shrink when microfinance enters, network shrinks. So think of these as being two different contexts. They're in different places, but they have similar results. Now, this is not necessarily surprising. Credit is one source of links. Obviously, one reason I don't visit Ben anymore is I don't need money from him. So I stopped talking to him. But you might then say that if I had some other, he was my partner for playing squash, then maybe I will still continue to see him even if microfinance enters. In fact, you see all links going down, not just, and that's maybe a little more surprising. But what's really surprising is the following. When you separate villages into two types based on their likelihood of getting a microfinance loan, so we basically we have a predictive model. We use who gets a loan. We can then map it to a certain set of characteristics, and we have done it in multiple different ways using some supply side characteristics. Right now we just focus on supply side characteristics. The microfinance organization, for example, won't give you microfinance unless you're a woman between 18 and 60 in your household. So if there is no one in that age range in your household, that you wouldn't get microfinance. So using a set of, so we can, and this is a very good predictor. The average loan, microfinance loan size is about 10 times bigger in the ones we predict. So think of it as two types. We define high types and low types, and we now ask, what happens to these people? And I think the obvious reason to look for this is that you might say, look, the high types, they get microfinance. Maybe they are busy with their microfinance lives. In fact, microfinance, in a sense, does make you more connected in one way, because they actually have meetings where you have to go, and so in the meetings you might actually meet some people, so other microfinance people. So in other words, what we call high types might increase their connections as a result of being in microfinance. The low types, if anything, you might think that their connections with other low types should go up, because what's happened to them is that the high types might be defecting from them. The high types might say, look, I don't want to hang out with you anymore because I don't need your loan. I'm getting my microfinance loan. So you might actually start cultivating your connections with the low types. Low types and low types. In fact, we find the opposite. The number of friends go down for both types, but much more clearly for the biggest change are on the LLs. So the people who did not get microfinance lose the most friends. Gosh, let me show you a table. This is from the experiment. So we can't control for pre-links, because as I said, this is cross-sectional comparison. The other one, we have exactly the same result from the other case as well, which is a panel, but it's non-experimental. This one is experimental, so it's not obviously influenced by any village characteristic, unobserved village characteristic. And you can see that basically the only people where there's a significant change are the LLs.
But in the experimental one, you don't have detailed pre-network.
We don't have pre-data, but this is cross-sectional. So we can just ask, do the LLs have less links in microfinance villages than in non-microfinance villages? So this is comparing LLs in the two classes of villages. The reason why we have to do the prediction, we have to do the prediction because, of course, in the non-microfinance villages, we don't know who would have got microfinance. So what we are doing is not actually who got microfinance, but who would be predicted to get microfinance in both classes using the same predictive model. So in other words, we are comparing like for like here. So you can see that this is the only one that's significant. They are the ones who lose their links. And that's true in the other case as well. Now, one thing that this says is that you have to think about how much design. So this is now interpretation of this. Let's think about what this is. So most obvious models tend to be of directed search of some kind. I value my connection with an L, I go meeting. None of those models are going to do work here. You need some model which has undirected search, basically. Some model where somehow the fact that the H's are dropping out is having spillovers on the L's. So almost you can think of any version of a directed search where I look for somebody, and it's also, so there's another possibility is one of these models that like Matt has, which is that where you do have spillovers. So if you have these, for example, in his quilts paper, you can imagine that when one link goes down, the others in that triad would also break. So you have spillovers, but those spillovers would say that if you look at the HHH links, those are the most robust there, because the H's are not losing links in general. So you would think that the HHH links are the ones that are not going to break. Okay. Sorry. The LL, if you think that what's going on is that the L's are now, you know, maybe the H's don't want to L. So if you think of the H, an H saying to an L, look, you know, I don't want to talk to you because, you know, I'm too busy now, I have my microfinance, then removing him will break all the HLL triangles. But the LLL triangle should not break as a result of that. So if you think the prime mover in this system is that the H's are all going out, then the HLL links should break, but not the LLL ones, and the LLLs go down the most. And if anything, they should go down the least. So it doesn't seem to be, it seems to come from something else. What does it come from? Our view is that it comes from some version of undirected search. Nobody goes to the village tea shop now, and now what happens is depends on exactly on the prior match rates. So who used to go there, and therefore, so if the L's did a lot of their matching at the tea shop, the fact that nobody goes to a tea shop means they don't go either. But then if I don't go to a tea shop as an L, then other L's don't meet me. So you need some model of undirected search to explain this phenomenon. So that's the case we make. So when we all retreat to Facebook, everybody else does so as well.
It's kind of a bowling alone. Like
yeah, exactly. There's nothing deep here. I'm just saying that, you know, you need something where the L's can't be, if L's could just go to hone in on other L's and meet them, then this shouldn't happen, because the L's actually need friends. In fact, we show that their borrowing from their friends goes down. So they are actually being hurt by this shrinking of the network. So they should be actually looking for people to borrow from. In fact, they can't, because they are, you know, the network formation process is not one where it's a lot of directed search, it's a lot of undirected search, and that's sort of the reason why you would see this. So sorry?
Wouldn't the LHs, because H's don't have any incentive.
Yeah, so LHs would go down, and in fact we find in the non-experimental study that the LHs go down. Here we can't reject 0. Okay, so I'm going to final question again. How much sophistication? How do we think about, you know? And I mean, I think there's very clearly, I think people have, I think, rightly taken the view that, you know, it's very hard to know what to make of information on a network. You don't know where the information came from. In particular, think of this example. You know, this guy sends a signal, this guy gets a signal, and you end up with 3 signals as a result. Now you don't know what to make of your second 2 signals. So that's your classic question here. So, and in particular, the question is, do you want to figure this out? Is it worth figuring it out? You know, think of what a Bayesian will need to do. He'll have to have a prior on all possible connections that people could have had, right? That's the exercise, and then he would have to integrate over that and say that, you know, I think that given the set of priors we have, this is the most likely outcome, and interpret the information that way. And that's a hard thing to do. In fact, people not just most people have a trouble naming friends of friends, let alone people further away. So if you ask people who the random friends of your random friend is, they can't name them. So I think there is a law. It's hard to imagine that they can do this exercise of kind of mapping out. I mean, of course, they can have priors over everything. If you were a wild Bayesian, you could imagine that they have priors over everything, even if people who they don't know exist. There's no reason why they couldn't, but maybe that's not so plausible. And I mean, there is this paper where, Daron and Asu have this paper where they work out what that would do, but it's not clear that there would be something is particularly worth doing. So a lot of people have argued, therefore, that it may be more sensible to use some rule of thumb for learning. And there are different rules of thumb you can use. You can use the majority of your signals. You can take the average of the signals. Whatever, you can do many different things. And this generates, you can sort of, this is, I think, now literature directly looking at this question. So you can have one implication of what the example I was giving is it generates correlation neglect. De Groot has this feature, but many models have this feature that, if I get 3 signals from the same source, I don't worry about that. I just count them as 3 signals. So that's one thing that you could do. And I think there is a nice paper by Benenke and Zimmerman showing that many people suffer from correlation neglect. So they have a nice lab experiment where they basically look at whether people put enough weight on the fact that these information could be correlated. The answer is no. There's this field experiment that Marcus and Adam did where they also look at this question. Their evidence is a bit more mixed, though my sense is that it's not entirely clear. Again, I think it's more sympathetic to correlation neglect than maybe they say. I won't spend too much time on it. And then there's the other, also in de Groot, which is you treat posteriors as signals. That's also a de Groot characteristic, is that you take the posterior and you treat it as a signal. You don't worry about its provenance. Where did it come from? So they have this very nice experiment, which is basically shows that this leads to underweighting certain. They have a live experiment where they construct games where essentially you look at this piece of information and you should say, if this guy keeps saying X, then it must be that he has more information than I think, because he should have changed his mind. But that's a kind of counterfactual thinking that you do as a Bayesian. You think about, what he should have said in different states of the world. He keeps saying it. So basically what you're doing is you're underweighting certain posteriors. You're not actually thinking about where that posterior came from, and you just treat it as a signal. Okay, it has the same precision. You treat it as if it has the same precision and everything else, but in fact it has a much higher precision. In their game they set it up. They have a much higher precision than, because essentially it reflects, the counterfactual is that they should have changed it. So relative to the counterfactual, the fact that they don't change certain behaviors means there's more precision there in that than you are giving it. So you underweight these posteriors basically. And so in this game they show that they do this both in India and Mexico, more mixed in Mexico. Mexico, they show that most people playing these lab games are better described by de Groot as a Bayesian, and about 50-50 in Mexico. In India, these are villagers. In Mexico, they're college students. So there might be systematic reasons why the college students are a little more maybe cheaper for them to think about it. Now, this is my essentially last substantive slide. I want to say, is de Groot reasonable? And one thing that de Groot doesn't do is it doesn't put any attention to uncertainty. And people seem very conscious of uncertainty. So we have a paper where we look at this empirically, and we ask people to rank other people's wealth. So between A and B, who's richer? So we have an experiment, this is in the AER few years ago, we asked them, tell us who's richer among A and B. And the answer is usually people just say, I have no opinion. So people are very conscious, and you can see who they are saying they have no opinion on. They're people precisely, we have a structural model, and the model predicts who they would say they have no opinion on, and those are people about whom they have imprecise information. So people are very conscious of precision, and they're unwilling to make statements that are too imprecise. That's a very non-de Groot characteristic. De Groot, you don't report anything on variance in a sense. That's sort of a very specific characteristic of de Groot. So people are clearly very conscious of and also, Ben and I were just talking about this. It treats all signals symmetrically over time. You could have, in a sense, in the de Groot world, you would almost say, first time somebody says something to me, maybe I should pay a lot more weight on it than the 400th time he says it to me, and it treats them symmetrically over time. So finally, we have a paper, the couple of papers looking at, or we don't have a paper to be specific, but we have some slides suggesting that noise in communication is quite damaging in de Groot. The main point is that I think we may need better competitors for Bayesian models, and in this non-paper we argue that some slower adjusting process is better. Basically, it does better with noise. So I won't get into that now. That's more a theory paper. So okay. So very interesting point. Network economics has been relatively open to the idea that, we always want to go back to particular kinds of optimization, and people are clearly not. I think thinking of people as supercomputers out to make money is not helpful. It doesn't teach us much. I also think that there is however, a temptation then to go to fairly mechanistic models, and I think the mechanistic models, part of it I don't object to, but I think we need to sort of not default to a mechanistic model. We should try to use, it should be empirical, the decision on which mechanistic model, and we don't have enough competition between different mechanistic models. It's easy to reject Bayesian. It's hard to reject. We haven't done a very good job of rejecting all the other models possible, and I think in some ways I think that's the relevant space we operate in, surely. But I think and likewise I think it's worth thinking of people's motives in a way that I think allows them to be not mechanical without giving up on trying to understand what they are. They're not mechanical. They are not necessarily aim towards making money, I think, but that doesn't mean we don't have predictive power. We just need to think about it. So, and here's my ending line. Thank you.
So maybe we can have time for a couple questions before we go on break.
So, we have these models of myopic best response. I'm also thinking maybe you could take a Bayesian approach where you don't go to the limit of inferring back to the beginning of time, but maybe you go back 2 periods.
Right.
How far does that go in the direction that you want?
I think some way. I did think of adding the literature on level n rationality. I think I guess the problem with that literature, if you like, let me say, I wrote one of the earliest papers in that literature, so I take some responsibility for it. I don't want to criticize the literature. I think it's a good literature, but I do think that it has the downside that has been mostly focused on centipede games and games where the level n part of it gets a lot of leverage, fairly complicated games. I'm not sure that that's the most useful direction to go so I like your idea of thinking about, for example, in a learning context, what happens where we think 2 steps back. That one I've never seen anyone do. So maybe it exists, but I've never seen it. Where it's done usually is in kind of symmetric information games of complex strategies. That's where it's usually applied. So it's not that you couldn't apply it, you could do it, but it's typically where there is some iterated weak dominance or something. That's where people apply it. So I think you're right that would be a good direction to go.
So I have actually 2 questions. So why do you think network economics is in a more special position compared to the rest of economies to accept these kinds of models?
It's an interesting question. I think largely because partly as a historical accident, I would say, but I think also because at some level we recognize that a lot of connections we make are just happenstance. We talk to somebody, we were on the bus who was next to us, or in the plane who was next to us, or whatever, and we learn something. And clearly, it's hard to imagine that those are, come from extremely clear economic motives. I didn't pay the person who was next to me. Usually, it would be awkward to do that, in fact, even if I learned something useful. So, I do think that, that recognition of how much happenstance dominates our life is perhaps more descriptive of, think of the other extreme, hedge fund managers. I don't actually think they are particularly competent, but they are very, very directed towards making money. They seem to, most hedge fund managers lose money relative to putting money in the stock market, as a point of fact. But nonetheless, they are very directed, and you can imagine exactly what they would do with a piece of information. So I don't think one should have a model that's particularly I think having a universal model of how people behave in all contexts is probably not useful. Maybe when hedge fund managers in a plane, they probably have casual conversations with people. They're not trying to figure out how to, and maybe they give them actually useful advice, but that doesn't necessarily mean that they use the same rule of thumb when they're dealing with their clients. So I just think that there needs to be a space within which we are somewhat relaxed about this idea that we have a very clear sense of why they are doing it. And so some skepticism, some understanding that people also like talking, etc., that might be an important part of understanding many of the behaviors. That's the point I was trying to make. So I don't know that I think it's not that it has to be networks. I think probably within families there's lots of understanding communication is probably super important. I've been trying. I've sort of now written hopefully a paper soon on exactly that, which is signaling within families. What do I say to what and I think it's super interesting, and that's not a network context. So there's lots of contexts where I think thinking about the most crass optimization is probably not the most useful model. Networks are a very natural context for that, because I think lots of our connections are kind of accidental or not obviously goal-directed in the sense that a hedge fund manager trying to make money would be. Yeah.
Just to add to that, arguably in other economic situations, there are institutions that more explicitly structure the interaction in a way that makes them amenable to modeling.
Correct.
Whereas we're more aware that our social interactions are unstructured, and it's up to sort of the theorist to impose structure on it. And the Bayesian one is probably
that's great. Especially hedge fund managers have very clear incentives to make money, and exactly, I agree with that.
Last burning question, or we go on break? Well, thanks again.
Thank you.